Good morning. Myself Kavitha, CSE Department, S.A. Engineering College, Assistant Professor, CSE Department, S.A. Engineering College. I am going to discuss about relational algebra in database management system. Database management system is a software or technique used to manage the data. So this database management system, here these popular databases are MySQL, Oracle, MongoDB, etc. This database management system can provide various operations, that is creating a database, storing in the database, updating an existing database, delete from the database. Then what is a relational model? The relational model represents how data is stored in a relational database. So the relational database consists of collection of tables, each of which is assigned a unique name. Suppose an example is that is considered relation student. This is a table, and this table is called as a relation. This contains columns and rows. These columns are called as attributes and these rows are called as tuples. So this is a relation. We are giving a unique name for this relation as student. Then the formal relational query languages, we are using two formal relational query languages, that is first one is relational algebra and relational calculus. Relational algebra is a procedural query language. I am going to explain what is relational algebra. So relational algebra operations we know the common operations, set operations are union, intersection and difference, and these main operations, that is these are selection and projection. These are the important operations in this relational algebra. These operations are used to select a row. The selection operation used to select a row, and this projection operation is used to select a column. Then operations that combine tuples from two relations. So to combine two relations, we are using the operations or Cartesian product and join. So after the result, that is after using these all operations, we have to get the relation as the return, that is relation as the output. So operations performed in single relation is, first one is sigma. Sigma is used for the selection operation. This is for used only for the rows, and this pi is used for the used to project the columns from a relation. And rename is used to rename the relation. So let's start with an example, that is this is a relation. The relation name is account. There are attributes. Attributes are number, owner, balance and type. So I am going to select one tuple from this relation using the sigma operator. So I can write this as sigma of, there is a condition here, that is sigma of C of R. This is the syntax for selecting a row. So sigma of type is equal to savings. This account is the relation name. So type equal to savings. So I am going to select a tuple from the relation using the sigma operation. So now listen, type is equal to savings, and type attribute is, here is the type attribute. Type attribute here is taking, and there is only one tuple is savings. So our output is like this: number, owner, balance and type. Savings, that savings attribute only we have to select as the output. This is how to select a tuple from the relation. The next is projection. Projection, for projections we are using the notation as pi. So here also I can give the condition as, it is attribute listers. We are going to project the attributes from the relation. So we can give this as the pi of the attribute list. This is attribute list, number, owner, type. This account is the relation name. So this is our table. This table name is, that is relation name is account. So the attributes are number, owner, balance and type. I am going to project the attributes that are the number, owner and type only. So the output is also a relation like this, only we are getting the attributes number, owner and type. So rename the operation. We are using this index row of R. I will explain this later. Set operations, common set operations are union, intersection and difference. So this is a normal case of a union operation, that is, this is a set A and this is B. How to get the answer for A union B? Here the repeated, that is repeated contents, that is no duplicates will be available in this resultant set. So let's see an example with the relation for union. Union, the symbol is, this symbol for union. So here there are two relations, checking account and saving account. The data are, that is like this, the attributes are the number, owner and balance. Here also saving account, here also number, owner and balance. So now listen, this is the checking account relation and this is the saving account relation. Just I combined both here, the output is like this. So one thing to be noted here, that is this union, if we want to take the union, intersection and difference, the two relations are union compatible, then only we can unite that two relations. So here these two the relations are union compatible if they have the same degree. Intersection is nothing but we are going to take the common tuples from that relation. So here in the checking account, this is a relation checking account and saving accounts. Look at here, there are 4 tuples here only one tuple. So the tuples 101, 102, 104, 105, here only 103. So what is the meaning of intersection? Intersection means we are going to take the common element from both the relations. So here is no common elements. So what will be the answer for this query? So here the answer is strictly these two relations are disjoint. That is the null set. The third one is set difference. So I will give a small example for this set difference. So this is a relation AB, that is R, and this is a relation S. I am going to subtract the S from R, that is R minus S. The condition is you have to write the elements of A which is not in B. That is, the elements of B should not included in this relation R. So here A1, A2, B1, here A2, B3. So you write all the elements of A, that element should not contain in B. So but here we have A and 2, it's in B, so don't write that element. So our answer is only A1 and B1. This is the set difference. I will give example from relation. So look at here. So this is the relation that is checking account and another relation is saving account. Here there are 4 tuples and here is 1 tuple. So how to find the difference of this checking account minus saving account? Checking account minus saving account. So what will be the answer? Here surely we are going to write the elements of A and which is not in B. So B element should not come to A. So surely the answer will be the checking account. Checking account relation is the answer for the intersection. So the difference. So combining tuples of two relations. So previous examples we have project select and find the set operations. So here we are going to combine to two relations, that is using the cross product and join operations. So for cross product, how to product two relations? So let's see with a small example. Here this relation contains 2 tuples and this relation contains 4 tuples. So if we cross product this, just to multiply this, that is we combine this to A1 and for all these elements from the relation S. So alpha 1, alpha 10A, then alpha 1, beta 10A, alpha 1, beta 20B, alpha 1, y10B. So finish the first step and then multiply with this B and 2 with all these elements. So we can get the 8 elements. All possible elements will come for the Cartesian product. Let's see this example. example with a relation. Here let's see. So here this teacher is a relation and course is a relation. So teacher contains two attributes and course contains two attributes. So I'm going to product these two, Cartesian product. So teacher into course. So let's see, first how to multiply these all the tuples with the first relation, first tuple of the teach course relation. So 105, 101, 105, 110 with all the 514. Then second step is 101, 105, 110 with 513, 513, 13. So totally 6 relations or 6 tuples are here. So when I told you when we have to use the rename operator. Suppose if we product this relation, this is a teacher into course, we can get these 6 tuples, that's no conflict. But if we multiply the teacher with the teacher, we can get a conflict at that time with the attributes. So we have to change the name of the relation. At that time we can use the row operator to change the name, rename the relation. So next is join operator. Join operator, here we can combine the relations with the common attribute. Okay, look at here the account relation has number, owner, balance and type. Then deposit relation has account, transaction ID, date and amount. We are going to join these two relations using one common attribute. So here common attribute, what they said, account join, the condition is number is equal to account deposit. So we are going to join the account and deposit relation if the condition is number is equal to account. So coming to the example, account is equal to account number. Here is, this is a number attribute and this is the account attribute. So just you come with this. Here 101, 102, 103, 104 and 105. Here also 102, 102, 104 and 105, but this is different. So first common tuple is, common number is, number equal to account is 102. So here also 102. So I can write this as the answer is 102. The next is 102 and 102. It is same. So again we can write this. Then 103 is not here common. So 104 is common to both relations, 104, and 105 is also common to both relations. So like that our output will be like this. But here one problem is both the attributes are same. Both the attributes are same number. So both the attributes are same, identical columns, and we have two identical attributes in the answer. So conditional join is, here is the two attributes, that is two relations R and S. Conditional join, that is equal to sigma of C of R into S. This we can use for the equal join and natural join. I will give the example for this. Let's see the gate questions. Gate questions. First problem is, given the relations employee, so given the attributes are for employee name, salary and department number, and department is another relation. Here the attributes are department number, department name and address. So our question is, which of the following queries cannot be expressed using the basic relational algebra operations? So question is, which of the following queries cannot be expressed using the basic relational algebra operation? So basic relational algebra, as I told, that is sigma, this is a selection operation, and pi is the projection operation, union, difference, Cartesian product and renaming. These are the basic operations in relational algebra. So our question is, which of the following queries cannot be expressed using the basic relational algebra operation? So the options are department address of every employee, employees whose name is same as their department name, the sum of all employees' salaries, all employees of a given department. So actually this question we can find the answer from the options itself. Just go with this department address of every employee. We can find the department address of employee from the relational table. Then here this employees whose name is same as their department, this also we can find it. The sum of all employees' salaries. Here is no option, there is no basic operations to find the sum of the employee salary. And final one is all employees of a given department. This also we can find from the basic operation. So what will be the answer here? Answer is the option C only, the sum of all employee salaries. So I will give the complete explanation for this. So how to find the department address of every employee. We can use the formula, that is pi of address. This all first we can product these two relations, employee and department. After the product, after the Cartesian product, you can select a tuple. You can select a tuple that is department number is equal to department's department number. That is two from the two relations, employee and department. We are taking the department number only. If the numbers are same, we are going to take, that is we are going to select all the tuples from the product table, that is employee and cutoff. Then you can project the address of each employee. So we can get the options using the basic relational algebra, that is department address of every employee. Like that we can find all other two options using the basic relational algebra operators, that is sigma and pi. So here the sum of employee salaries, there is no basic operations for the sum of all employee salary. So this is your answer. This question is, this gate question is gate question, computer science 2010 is an important question. Second problem is, consider the relation R1. There are two relations, R1 and R2. The attributes are P, Q and R, and for R2, R, S and T. So there are three attributes here and here three attributes, the two relations with the primary keys P and R respectively. The relation R1 contains 2000 tuples and R2 contains 2500 tuples. The maximum size of the join R1 and R2 is, so this is also a gate question, computer science gate question 2005. How to find the maximum size of the join of R1 and R2. R1 and R2 are the two relations. So if we product the two, that is we can get more than 2000, isn't it? So 2000, that is 2000 into 2500, it will get, we can get more tuples. But the options are 2000, 2500, 4500 and 5000. So how can you find this? So I explained that this join, the condition for join is, that is if you want to join the two relations account and deposit, here there is a condition, number is equal to account. So look at here number and account, here 1, 2, 3, 4, 5. Here 5 attributes, 5 tuples are there. Here there is 4 tuples, but we can get only 4 tuples as our answer because there is common attribute should be there. So like that. So here this relation contains 2000 tuples and this relation contains 2500 tuples. How can you find the answer? So here these are the primary keys P and R respectively. Look at here, this is R and this is common attribute for both relation. This is common attribute. So here R is not a primary key, but here R is a primary key. But anyway, there are only the 2000 records for the R, 2000 records for the relation. So we can say the answer is 2000. So easily we can say that as it is a guess, so in way it is easy to say this is the answer is 2000. So consider the relation student name, 6 marks and 3 attributes. The relation is student where the primary key is shown underlined pertaining to students in a class that has at least one boy and one girl. What does the following relational algebra expression produce? So this relation algebra, this is the syntax for getting one of the options. So which is the option? Find the option. So here we are using the operations pi, that is this projection, and the joining operator. So first we have to find the relation join with this student. The result is the solution. The query first computes join where marks are less than or equal to marks are less than or equal to max marks. Then select the name of the girl students with more marks all the boys. So our option D is the correct option. So we can find it from here itself. Here we are just taking the project the name of the females, and here take the marks less than the male. So we can take the answer as name of girl students with more marks than all the boy students. That is the answer. Then fourth problem is the same like that. There are two relations, that is student information and enroll. Here are 3 attributes and here are 2 attributes. So the question is, what does the following relational algebra expression represent? So from this we can find the answer as, so first you have to select the student ID of all females. That is, we are given this relation student information, select sex equal to female. So this is the girl students and project the student ID of all the females. So our answer is courses in which all the female students are enrolled. Thank you for giving this opportunity.